working with our systems of equations, we're going to have to first of all read the problem that we have to solve, and then we're going to have to decide what are the unknowns in it, what are the things that can change in this problem, because there should be two unknowns in the problem. We have to pick those out, identify what they are, and then we assign a variable to them, okay? So let's just take a look at this first one on the front side here where it says, set up a system of equations with two different variables. We'll use x and y because of the graphing. Use a graph to find the solution. So we have the situation. Several books are on sale at a bookstore. Some of these books sold for $3, while others sold for $5. One day last week, 80 books were sold. The total amount of the sale was $300. How many of each type was sold? So typically, after you read through the problem, when there's that question at the end, typically that question at the end will kind of lead you into what are the things that are unknown in this? What are the things that can change? So it says, how many of each type were sold? So notice what I did. I already picked what our variables are going to represent. So would you put a box around that, please? The things that can change in this problem, the unknowns are how many $3 books did they sell and how many $5 books did they sell?
Could there be different numbers? Like they could have sold no, I know if it's only 80 books.
Yes. Considering that in this situation, there is only going to be one correct answer, okay? We are looking for how many. Now, we could just do a bunch of guessing and checking and putting together different combinations until we got it to work. But what we're going to do is we're going to set up a system of equations, and we're going to use, I've also started this out here saying if you would use the number of $3 books and add to that the number of $5 books, you should be able to get the total number of books. Do we know any of that information? Do we right now know how many $3 books were sold?
No.
How about $5 books?
No.
No? How about total number of books?
Yes.
Okay, so what equation do you think we could set up using that information? Christian?
3x plus 5y equals 300.
So there's 3x. Well, what will 3x give us? What would 3 times
The
x?
number of $3 books?
So 3x would give us the number of $3
Oh,
books.
that would just give us the amount of money the $3 books were.
Yeah, that would tell us how much money they sold in $3 books. Wouldn't it? If they sold 10 books, let's say, at $3 each, how much money would they take in?
$30.
$30. So would 3x represent the number of $3 books?
Maybe 3y.
Well, look at what I said up here. I had you box it. Look at what I said. Let x represent the number of $3 books. Let y represent the number of $5 books. So what equation could we use?
X times y, no, x plus y equals 80.
So x represents the number of $3 books. Add to that the number of $5 books. And altogether you should have 80 books. Right?
Yeah.
So on our system of equations, we're going to have both an x and a y, and we're going to have two equations. So we right now have, let's go ahead and start our system of equations right over here. Remember, we put that fancy bracket off to the side to show these equations are going to work together. So we have x plus y equals 80. Okay, then I kind of got to set up here for how could we write another equation, and look at what I say we could use. The dollar sales of $3 books plus the dollar in sales of $5 books should equal the total dollars in sales altogether. Ricky?
So this one is actually the 3x plus 5x or 5y equals the $300.
Okay, so money plus money, 3 times the number of books should give you dollar amount sold in $3 books, plus 5 times y. Y is how many books there are, 5 times that. Should tell you how many dollars they took in sales of $5 books. Altogether, their sales were $300. So here's what you always need to pay attention to when you're setting up your own. Students often say, I cannot figure out how to set up my own equations. Well, here's one way to help guide you. Don't do this. Books plus books equals money. money plus money, somehow it turns out to be books. Make sure that what you're adding, subtracting, whatever you're working with, when you put it all together, you still have the same thing in the end. So setting x plus y equal to 300 would have made no sense. Number of books plus number of books equals $300. That make sense? So here's our other equation, 3x plus 5y equals 300. Well, right now, we only know one way to solve a system of equations, and that's by graphing. So we need to get these ready to graph. So first of all, are they in graphing friendly form? No, what's that form called? That no, standard. This is standard form, but what's the graphing friendly form called? Slope intercept form. So let's get each of them ready to graph. Let's start with x plus y equals 80, and then we'll work with the other one right next door here. 3x plus 5y equals 300. Okay? What do we have to do to that first one? Okay, how do we do that? Okay, subtract x from both sides. Okay, so now what's our equation read? Okay, y equals negative x plus 80, or 80 minus x, but this is now in the actual slope-intercept form, y equals mx plus b. So now we're going to identify our slope. What is it? Negative 1. And what's our y-intercept? 80. Now notice I left a little space between my slope and my y-intercept because we need to talk about that slope. And whenever we are going to not have a scale of ones going on our axes, we have to make sure we process through first and say, can I do the same thing I would do on a graph where the x's are going by ones and the y's are going by ones? Right now, that's what we've been graphing mostly, so we just say, if there's a slope of negative 1, we go down 1, right 1, or we go up 1, left 1. But we have to be maybe more cautious today. So the first thing we're going to do is we're going to get our graph ready. What title should we give the x-axis? $3 books. Okay, let's write that below there. $3 books. Didn't give us a whole lot of room, sorry about that. And then, what are we going to call our y-axis?
Books.
$5.
$5 books. Okay. And then, looks like I've already chosen the scale for you for both of your axes because I want us all to have the same graph. So what are the x's going by? 5. Okay, so we need to number that out. Now, do we have to number every grid line?
No.
But do we have to count every grid line as 5?
Yeah.
Yes, we do. So numbering every one kind of gets a little busy, so you might want to skip and not label 10, but then go to 15. So go ahead and number out your number line, your x-axis, which is like a number line. The last grid line on the x-axis should represent how many books? 100 books, yeah. It is 100 books. Okay, what's our y-axis going by?
Same thing.
Same thing, so we're going to number that. And our y-axis, we can go how far? 100 books on that one too. Okay, so now we're ready to start using it. Let's put our first point at 80. And then, before we start graphing, we have to, because the scales are both 1, we're not going by ones, we have to stop and say to ourselves, if I go down 1 on the number line, am I really going down 1 book? How many books am I going down? 5 books, right? Okay, so I'm actually going down 5 books. And if I go over 1 on the x-axis, am I really going over 1 book? I'm really going 5 books, okay? And the reason we have to do that is we have to stop and say, would that still be the same thing? Is doing negative 1 over 1 equal to negative 5 over 5? Yeah, they're equal. Both of them really equal negative 1. So we can get away with it. But we have to make sure that they do, okay? So in reality, because -1/1 simplifies to -1, and so does -5/+5 simplify to -1, we really can go down 5 books then and over 5 books. We can go down 5 books and over 5 books. Would you make a whole bunch of points, please? Because you know what? On these especially, we have to see clearly where these lines are going to intersect. So we need lots of points. Like 100 or so. And these are easy to make. Should we extend our line outside of quadrant 1? Why not? What happens if we extend it up here going into quadrant 2? We'd have a negative number of $3 books. What if we extended it down here into quadrant 4?
Negative.
We'd have a negative number of $5 books. Can't have either, so we're just going to connect the x-intercept and the y-intercept and say these are the only ones that make sense. Okay? So now we're ready to get our other one ready to graph. What should we do? Add 3x to both sides? Is that what I heard? Subtract 3x. Oh, okay, maybe I just didn't hear right. Or it was the typical 9th grade mumble. Just comes with the territory. Divide by 5, okay. Divide every piece by 5.
Y equals 60 minus -3 x.
So we could either call it -3/5 x, or we could make it plus, or we could just rearrange it and say this is -3/5 x plus 60, right? Okay, so what's our m this time? -3/5. Now, before we even decide what b is, let's just take a moment and let's evaluate whether we're going to be able to do down 3 over 5. Let's check it out. So if we go down 3 over down 3, let's just talk about that first. In reality, if you go down 3 on the y-axis, how many books is that? 15. Okay, so that's a -15. If you go 5 right on the x-axis, that's really 25 books. Okay.
Oh.
How do you feel? Do you feel like we can do that?
Yeah.
Same, yeah, they're equivalent, aren't they? Okay, so we can go. So we're going to now identify our b though first here. What's our b? 60. What's our starting point? It's 60. So we'll start at 60 and go down 3 over 5. Okay, and again, make enough points that it doesn't hurt to go all the way from one axis to the other and get a good graph. I found a point of intersection on mine. How about you? Okay, so what is that ordered pair where they are intersecting? 50. Did I hear 50 what? 30? Okay.
I'm not done.
Okay. So they should, your lines, if you graph them correctly, they should intersect in order to 50, 30. But then, you know, when we're done graphing these, because we know what x and y represent, we don't stop there and say, okay, the solution is ordered pair 50, 30. We explain what that means. So what does 50, 30 tell us?
There's 50 feet on this and 35.
Yeah, there were 50 of the $3 books sold. So this is what's important in this one. Let's circle that. 50 of the $3 books were sold. And how many of the $5 books? 30 of the $5 books were sold. Okay? That's really what that ordered pair solution is telling us, because we know what X and Y are representing. When we check our answer here, here's how we're going to check this, okay? We're not going to worry about that we set up any equations. We're just going to go back to that original information and pretend that we did guess until we got it to happen. What was one thing that we knew had to happen? How many books did they sell? 80. So we're going to say, you know what? Well, we found out that there were 50 $3 books and there were 30 $5 books. That added together is 80. Do we feel good about that?
Yes.
Okay. Well then, what else? We know that if 50 $3 books sold, we could take 3 times the number of books, and that'd be 150. Okay. And then we would take 5 times the number of books of that price that sold, and that just happens to also be 150. And when we add up those two sales, it is 300. So it seems like we have a pretty good answer, doesn't it?
Yep.
Oh.
I was still graphing.
Okay, so let me just reinforce with you the things that you need to do for these work problems. You have 3 of them to do on your homework, okay? And you need to, first of all, you need to start by identifying what are X and Y going to represent. I did that for you in this one, but I had to put a box around it so it draws attention to it. You have to set up your own system of equations. Then you graph your system of equations, and then you answer the question that was actually being asked. And the question was being asked in this one was, how many of each type was sold? So we said 50 of the $3 books sold, 30 of the $5 books sold. We don't just give the ordered pair answer. So any questions before we move on to our other one that we're going to practice? Okay, go ahead and turn over to the back side. You read that problem and you start deciding. In fact, write something down. What do you think X and Y should represent in this one? Okay, who's our Friday genius? Oh, Isaiah's going to think to be. Okay, Isaiah, what should we let X represent from this problem?
I picked to have X represent the cost of budget burgers charged per person.
The cost of budget burgers charged per person. So that's something that can change? Budget burgers willing to let that be whatever? You said let X represent budget burgers charged per person. Is that what you said? So, can that change?
No.
What are they going to charge?
$10 every time.
$10 for every person. That doesn't get to change. X has got to be something that can change. It has to be, flexible. Sam?
The number of people that are going.
Number of people that are invited. How many of you agree with that? The number of people. Can that change? Does it say how many you have to invite? No, that's a good choice. Number of people. Let X represent the number of guests or number of people, however you want to call it. Okay, so how many people is Derek going to invite to the party? That can change. You know what? It could be 2, it could be 20, it could be 200. Okay. Well then, if X is going to be the number of people, remember that's X, the X variable is always in charge, always in control. So it's controlling the situation. So considering then that however many people you invite controls the Y value, what should the Y value represent then? What do you think there? Okay, I'll give you another chance, Isaiah.
That time it should represent the cost per person.
Cost per person? Oh, we knew how much it was per person.
That's true.
$10 a budget burger. It's how much a banking room? $8.
The total cost per person.
The total cost per person?
No, the total cost altogether.
There you go. It's just the total cost. How much it's gonna cost Derek to have this party catered is dependent upon how many guests he invites. And right now, it doesn't matter where they come from, we're just trying to say, what can change in this problem? What does he have control over? Okay, so go ahead now and try and write an equation for Budget Burger and for the Viking Room, because the question is, when would the cost, find the number of people for which the total cost is the same for both. So that's what we're solving for. So we have these two unknowns. We should be able to set up two equations. Okay, who thinks they know one of them? Okay, yeah, which one do you want to give me?
Budget burger.
Okay, what's Budget Burger's equation?
Y equals 10x plus 110.
Anybody want to agree with Ian that we could go with that equation? It's looking fairly popular for the moment. Okay, how about the Viking Room? What are you going to do for that one, Hunter?
Y equals 8x plus 150.
Okay, anybody want to agree with Hunter? That would be a good one for the Viking Room? Yeah, we got some good equations here. Total cost for Budget Burger is, well, you know what, it's $10 for every person plus $120 just because they're going to show up and do it for you. And then Viking Room, same thing, total cost, they're going to charge you $8 per person. They charge you less per person, but they have a higher starting cost, don't they? Okay, so there's our system. So let's just do this. Let's just put a nice little fancy bracket on right there saying these two are going to work together, folks. Are they in graphing friendly form? Love it. Oof, we don't have to work very hard then. So y equals, let's write it down though, because you know we do have to evaluate what are we going to do with that slope when the scales might not go by ones. And I've already picked it and it looks like one of them's not gonna. So what's the slope of this one?
10 over 1.
10 or 10 over 1, okay. And the b is 120. I'm going to write them side by side like that because we need to think about that slope and make sure, before. But before we do that, we better get our graph ready. So on that graph, what title are we going to put on the x-axis? What'd you say? Number of people. Okay. I'm going to put number of guests. That's what I call them. But you can say people. That's fine. And what's the x-axis going by? One guest at a time, right? Okay, so go ahead and get that one numbered out. And then what's on the y-axis? Total cost in dollars, okay. And is it important that we put the dollars? Sure is, because it could be in what? Cents, or it could be in thousands, or it could be in, quarters, yeah. Okay. So what's the y-axis going by? How many dollars at a time is the y-axis going? $20 at a time. So let's get that numbered. According to my numbering, our coordinate plane is going to hold up to 20 guests and $400. Is that what happened when you numbered it?
Yeah.
Okay. So, where are we going to put our first point? At 120, okay? So, at 120, we're going to put a y-intercept, our starting point. From there, we're supposed to use a slope of 10 over 1. Okay, so I want us to do this. 10 over 1. If we go up 10, that's $10, or 10 grid lines on the dollar. So is 10 going up $10? It's $200, isn't it? So we need to put 200 here, because you know what? It's not really, if we go up 10 grid lines, it's really $200. That's really a $200. Okay, well then if we go over 1, how many guests is that? Just 1 guest. So did we keep the relationship? If we go up 10, like we, this is what we would typically do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we go over 1 and we put a point. Are we gonna be right?
No.
Is 10 guests over, or not 10 guests, $10 over 1 guest the same as $200 over 1 guest? No. So we're gonna have to rename this. We need, if we wanna go up to if we wanna go up $200, that's kind of a lot. How about we go up $20 at a time, or $40 at a time, or where do you wanna go? 20?
Oh.
So 10 over 1 needs to get multiplied by, both the upstairs and the downstairs need to get multiplied by 2, so that we can go up $20, which would be how many grid lines? 1 grid line, and over 2 guests, which would be 2 grid lines. So you're gonna have to do some critical thinking for graphing these. You can't just do, like rote, like we've been doing, up 10 over 1. No, that's gonna mean you went up $200. So we're gonna go up 1 over 2. 1, 2. Make them all the way, seriously, make them all the way out till the coordinate plane runs out of spots for you to do them, okay? You're gonna need them. This is gonna be a very tight graph. Can I put an arrow at the end of this one?
No. Yes.
Yeah, can the number, is there any limit to how many guests you can let? No? Okay.
No.
But we don't want to go back into quadrant 2 or quadrant 4, because that would be negative number of people. We don't want that. Okay. So there's that one. Yeah, I didn't leave myself a whole lot of room. Hopefully you left yourself. I'm going to have to go over here and do the other one now. Y equals 8x plus 150. What's my M and what's my B? M is 8 over 1 and B is 150. Okay, well, 8 over 1. If we really do go 8 over 1 on this graph, we would be going, I'm going to move that B equals 150 over a little bit here. If we really do go up 8, what's supposedly be $8, do you really want to go up just $8 at a time?
No.
Because would that be a little difficult? Like each grid line is how much? 20. Let's see, 8 is what part of 20? Yeah, we don't even want to figure it out, do we? We want to go up we want to be able to go up in increments of 20 here. So are there any multiples of 8 that are also multiples of 20? 40. So if we could rename this, if we would take this and rename it by multiplying 8 by 5 and getting 40, then we'd have to take the downstairs times 5 also, right? Because it's 40 over 5, the same as 8 over 1. We did lose the slope's value, but now we can go $40 at a time and 5 guests at a time.
150.
So we have to start at 150, which is, oh, it's not even where I just put it. I put it in a wrong spot. It's a halfway between grid lines, isn't it?
Yeah.
Yeah, well, that's all right. That's not the end of the world. We can do that. So we'll go right here halfway between 140 and 150, and we'll put a point. Halfway between 140 and this is 150 right here, that grid line. So I'm halfway. What? Did I do something wrong? Okay. That's a 180 there. You can't read it. It's kind of. Oh, that would be 160. You're right. Thanks, Riley. Yeah, don't be afraid to speak up. I was not hearing. Okay, so this is 150. We're going to go up. What do we say? $40. So we'd have to go up $40. So we're going to be halfway between it, and then 5 guests over. So be really careful. Up $40 over 5 guests. Up $40 again, over 5 guests. Up $40 again, over 5 guests.
Oh, it didn't cross right there, but it was close. That's what it
I feel like something's wrong on mine. Yeah, I did something wrong. I gotta go back. Okay. And of course, draw your line. They're going to be pretty tightly close together. And here's the other thing we're going to do. We're going to give each of them their name. We're going to call Budget Burger BB. We're going to call Viking Room VR. Okay? So the first one we graphed is our Budget Burger line. So you put that at the end of it and at the beginning of it so you can follow it. So the first one we did was our Budget Burger. It's representing Budget Burger. And the other one is representing Viking Room. So we want to put that at the beginning and the end of it so we can tell. Did yours intersect?
Yeah.
Can you tell where they intersect? So what does it look like?
10 to 20.
No, that's not it.
15 and 2.
It's 15 and 270. 15 270 is where it should be. So that's where you want it. 15 270 should be their point of intersection. Once we get to learn how to solve these algebraically, you're going to like solving these type algebraically a lot better. But till now, this is all we can do. When Derek invites how many people?
15.
15 people. The total cost will be the same. That was the question, so let's circle that. That's what we had to answer. We don't just leave our answer as the ordered pair. We say, you know what? When Derek invites 15 people, the cost is the same. And what is that cost, by the way? $270. Okay? But then they want us to do one more thing. Cole, would you read to us what they want us to do next?
Explain when it is cheaper for Derek to hire a Budget Burger to cater his party and when it is cheaper to hire the Viking Room. Include in your explanation how the graph supports this.
Okay. So when is it cheaper to hire a Budget Burger? Ricky?
Anywhere past that point, before that point.
Okay, and how does the graph support that?
By showing that it.
Here's Budget Burger. So you're saying anywhere before 15?
Yeah, because it's below the Viking Room.
Yeah, because the line is lower, the Y values are lower there, and that's the total cost, isn't it? Okay, so we're going to say when Derek invites less than 15 guests. Oops, I forgot the word "than" in there. Budget Burger is cheaper. And we're going to say the line. Maybe we should say its line, so we know what line we're talking about. We're talking about Budget Burger's line. Its line, and that's not possession. There's no apostrophe there. We don't say it is line. Its line is below the Viking Rooms.
Wait, 15 guest Budget Burger?
Invites less than 15 guests.
Actually, that says budget.
When Derek invites less than 15 guests, budget,
Burger is cheaper.
is cheaper. Good job, Ricky. Oh, what did I eat for lunch?
Budget Burger.
Apparently I wanted it. Budget. There we go. Budget Burger is cheaper. Its line is below the Viking Rooms. Now there's possession going on here. line. Okay, so when would Viking room be cheaper?
Morning pass.
Okay, Viking room is cheaper. For more than 15 guests.
Uh-oh, running out of room.
Yeah, we won't talk anything about the line for this one. We know that we had to look for where the line was now still.
Are we gonna have to write this much in our homework?
You might.
Oh no.
So the Viking room line gets lower past 15 guests, so then that means it is cheaper for them. So if he's going to invite 15 people, doesn't matter which place he goes with.
No, Cole's getting.
But if he wants to have a whole lot of people at the Super Bowl party, he should go with which one? The Viking room. Okay.
Personally, if he invited 15 people, I'd go with Budget Burger.
Oh, you mean if?